All right, sports fans, listen up. I hope you are enjoying your day off, your 3-day weekend. I hope you enjoyed it. You're back now. You're stuck at school. But not me. I'm gone. So you're listening to this video of me explaining our upcoming project for fourth quarter. This is a big one. We're going to be creating 2-liter bottle rockets using 2-liter bottles. That's why we call it a 2-liter bottle rocket, right? The goal of this particular project is to create a rocket that will stay in the air for the longest possible amount of time. Okay? We're not necessarily worried about height. We're not necessarily worried about it surviving when it comes back down, but we want your rocket to stay in the air as long as it possibly can. So that's your goal. How you accomplish it is really going to be largely up to you. Today you're going to start a process of researching and designing your bottles, and you're going to be launching these rockets more than one time. The first time you launch, we'll get an initial result. How long does your rocket actually stay in the air? And then you'll have a chance after you've launched and class periods after that to redesign and to rebuild. And your grade will be mostly based upon your ability to create a rocket that beats your first rocket, right? So we're looking for improvement. Don't worry too much about your first rocket being as best as it possibly can be. That's where we try out things like fins and parachutes and propellers and nose cones and stuff like that, okay? Now, a couple of rules you need to keep in mind. One of the bottles that you use has to be unpunctured and uncut completely. We will pressurize this bottle using air and water, and it is going to come screaming off the launch pad. This cannot be cut and then taped or glued or epoxied or Gorilla glued or anything. It cannot be cut in any way. All right. Now, if you choose to use additional bottles to attach onto this to increase the length or how wide it is, that's perfectly fine. Those bottles can be cut, they can be manipulated, they can be melted, they can be folded, taped, whatever. But your initial bottle that we put water in and then pressurize the air inside of it cannot be cut or punctured in any way. Okay? The launcher will grab onto your rocket on this little plastic ring right here. So whatever you design, we have to have access to this bottom portion here for those claws to hold on to it. And when it releases that pressure and that bottle shoots up, that thing's going to take off pretty quick. All right? So I want you today to begin, after forming your groups, start to do some research so that you can design and draw what you want your first rocket to look like. You can't use any metal, okay, or very heavy wood on this because these are going to be coming off the launch pad at like 70 miles an hour. So we have to keep it safe, okay? You also have to submit a design, a rocket design, before we're going to let you actually start building these. All right? Other than that, folks, use the internet. Check what other ideas people have done in the past. We're not the first class to have done this assignment. Go ahead and take a chance on this first round because we're looking to improve upon it. If you're curious as to how something is going to work, then try it out on this first rocket and we can make changes from there. Okay? Groups can't be any bigger than 3. I actually recommend you do in probably pairs. And if you really feel like I want to do this one on my own, I have some ideas and I don't want anyone to change them, then you can work solo on it as well. Okay? But you need to be researching and you need to be designing and drawing what you want these rockets to look like, and it should include a materials list. What do you need to pull off your rocket? Okay? I can't wait to see your designs when I get back. Have a wonderful day.